Hi, today we'll be looking at how to test an equation for symmetry. That's going to be our area of concentration for today. Now, before I begin to talk about all what we have here, let's go ahead and look at an example here so we can have at least an overview of what we're talking about. Now, the question here says, list the intercept of the equation below and test the equation for symmetry. So let me start by writing the solution. So the equation we are given is x squared minus y minus 4 equals 0. We want to start by finding the intercept, and then later we'll test the equation for symmetry. Now, looking at this equation here, I could rewrite my equation by bringing my y to this side. So this becomes x squared minus 4 equals y. Or you just say y equals x squared minus 4. Now, to start solving this, I want to start by finding the intercept. So listing the intercept. So the intercept we have, since we are dealing with the Cartesian plane, the only kind of intercept you can think of is just the x-intercept and the y-intercept. So let me start by finding the x-intercept. Now you would recall, the x-intercept is just the value of x when y is 0. So to find the x-intercept, I need to set y to be 0 in this equation here. So set y to be 0, and then when you set y to be 0, what we'll have is going to be x squared minus 4 equals 0. So we want to find the value of x that satisfies this quadratic equation. Now you recall this is the difference of two squares, which has been explained in the previous video. So this is the same thing as x minus 2 into x plus 2 equals 0. And when we solve this, so this is going to give us x equals 2 or x equals negative 2. So that is to say, when x is 2, so these are going to be the two coordinates. When x is 2, y is 0, or when x is negative 2, y is 0. So now I found my x-intercept. So it remains to find the y-intercept. Now the y-intercept is just the value of y when x is 0. So since I want to find the value of y when x is 0, all I need to do is to set x to 0. So I'll set x to 0 in this original equation here. So what we would have is going to be y equals, so in place of x, since we now have it to be 0, it will be 0 squared minus 4, and that will be negative 4. So that simply says that when x is 0, y is negative 4. So this is the y-intercept. So I already found my x-intercept and my y-intercept. So I've answered the first question here. So it also asks another question. It says, test this equation here for symmetry. Now, to test an equation for symmetry, there are three things which you need to check. So you're going to check if the equation itself is symmetric with respect to the x-axis. You're going to check if it is symmetric with respect to x-axis, with respect to the y-axis, and also with respect to the origin. Now, to check if an equation is symmetric with respect to the x-axis, all you need to do is, wherever you find y, you replace it with negative y. Now, after doing the replacement, if what you get is the same thing as the equation, it implies it is symmetric with respect to the x-axis. And then for the y-axis, to check if the equation is symmetric with respect to the y-axis, you replace x with negative x. If the equation you get, or the resulting equation you get, is the same thing as the original equation, then that implies it is symmetric with respect to the y-axis. And then the same thing holds for the origin. So since I want to check if this equation here is symmetric, so let me start by checking if it is symmetric with respect to the x-axis. So I'm going to replace y with negative y. So the first one is to check for symmetry now. So now symmetry with respect to the x-axis. So we said we'd replace y with negative y. So what I have here is the original equation is y equals x squared minus 4. So I'm going to replace y with negative y. So you have negative y equals x squared minus 4. And then when you simplify this, this is the same thing as y equals negative into x squared minus 4. But when you compare this, what we have here and what we have here, they are not the same thing. Why? Because here has a negative sign and here does not have a negative sign. So that implies it is not symmetric. So the equation is not symmetric with respect to the x-axis. So let's keep on going. Let's check symmetry with respect to the y-axis. Now to check for symmetry with respect to the y-axis, all we need to do, according to what we have here, is to replace x with negative x. Since the original equation is y equals x squared, so let's just write that again, y equals x squared minus 4. So to check for symmetry with respect to the y-axis, we would replace x with negative x. So this is going to be y equals negative x. So you need to put the square to affect everything here, minus 4. And negative x all squared is going to give us y equals x squared minus 4. And then you will observe that what we have here is the same thing with what we have here. So that implies that the equation itself is symmetric with respect to the y-axis. And then lastly, to check if the equation is symmetric with respect to the origin. So which is the origin, which we are about to check. The origin. So to check for symmetry with respect to the origin, what we do is we replace x and y by its negation and then see if it is the same thing with the original equation. So since the original equation that we have is you have y equals x squared negative 4, so we're going to replace what we have here, that is my y with negative y equals negative x all squared minus 4, and this is going to give us negative y equals x squared minus 4, and then which is the same thing as when we multiply both sides by negative y, we have y equals negative x squared plus 4. So what we have here and what we have here, they are not equal to each other at all. So since they are not equal to each other, so that implies that the equation is not symmetric with respect to the origin. So it's only the y-axis that passes the test. So hence we may conclude that the equation y equals x squared minus 4, which is the original equation, is symmetric with respect to the y-axis, and that completes the problem.